A common application of differentials is to find the volume of a shell painted on the outside of some object. So in this case, we have a cube that measures 5 inches on each side, and we're told we want to find the amount of paint, the volume of that paint that would require to paint a 0.04 inch shell all the way around the cube. What I'm going to do is I'm going to say we have this cube is going to be essentially extended by 0.04 inches on each side, just by virtue of painting that shell on it. So here we're going to do, we're going to apply the differential. We're going to take the derivative of both sides of this equation to get dv equals 3x squared dx. Bear in mind that this is a differential, so it looks a little bit different than your usual derivative, but differentials are used to help us find the volume of this shell. dv will be the change in volume, so this is our answer. Our answer will be, what is the change in volume of having a cube that doesn't have a shell, a naked cube, so to speak, and then what's the volume of the cube with the shell on it? That dv is the change from the naked cube to the painted cube. X is the value of x that we already have on top, or basically the value of x is the side length of the not the shell but of the cube. So we have 3 times 5 squared. Dx is the thickness being added to the edge of the cube. Now in this case you might say it's just 0.04, but it's 0.04 added this direction and 0.04 added this direction. So that's going to be a total of 0.08. That's your dx. Dx is the amount added to the side length by virtue of painting the cube. Okay, so now all I have to do is evaluate this expression. 5 squared is 25. 0.08 is 8 divided by 100, we'll say that. And this is going to make things a little bit easier because 25 divided by 100 will be 1/4. And then I'll have 8 divided by 4 is 2. Times 3 would be 6, and that is your final answer.